Hello, hope everyone is doing good, and I know that everyone will be preparing for like JEE second attempt right now. And there is a say that January shift, right? Everyone must be knowing about the January shift, like chemistry. So, like some of the questions are given below. I mean, it's given here, and I know that chemistry shift of January. I mean, chemistry of the January shift was little bit trickier or lengthy. It is the common say, right? But actually, if you see the questions of chemistry, you can see that the concept has been repeated as it is from the PYQ, not the question as it is. But most of the questions, rather than one or two question in an attempt, all other questions came from the PYQ concept. Okay, it's not like PYQ as it is repeated, but the concept of the PYQ is used to create another question. So, for second attempt, if you study chemistry in a proper way, analyzing each of your PYQs including the first attempt, okay, in a proper way, definitely it is easy to score 99 percentile and plus for chemistry. So let's just take some of the examples in like some of the questions from the first attempt, and let's see. See, this is about the hybridization and shape. Okay, statement 4, ClF3, all three possible structure may be drawn as follows. This as it is NCERT if you see it. So this is correct actually, right? Those who know about the hybridization, VSEPR theory, so this part is from VSEPR theory. Now see, structure 3 is more stable as the orbitals having the lone pairs are axial. We know in TBP structure, the lone pair has to put in the minimum repulsion, that is at 120 degree each other, right? So this is where actually putting, and that is why it is getting the T shape ClF3. So this is actually a PYQ. The shape of ClF3 has been came as the PYQ. The questions of the most stable structure of ClF3 has been came as a PYQ. So make sure when you are reading this question, you are doing all the concept of the PYQ and you are restudying the thing. For example, this is VSEPR. In VSEPR itself, you have Benz rule where you know that where you should put lone pair, and the not only lone pair, you should know where you have to put the more electronegative atom. For example, fluorine is more electronegative, right? More electronegative atom, for example fluorine or whatever electronegative atom, you should put in less percentages character. So the concept is repeating. You can get some other question related to this concept. So whenever you are like taking a PYQ, make sure you are taking or you are learning the concept properly, so that if the same kind of questions or same related question is coming, you can do that. So there is now another example of P block given. So whenever you are reading P block, don't think that P block is very tough or there is a lot of things to remember. Again, take the PYQ. For example, this question you see, this question is as it is from PYQ again. So the melting point, each order, the trend of the, what is the syllabus? The trend of the groups, right? The trend of the groups, and there's a particular period and particular groups. So those alls are repeated, whatever is repeated in PYQ, take that and study it properly so that you are not forgetting it. Okay, don't need to like you don't have the time for that. Also, you don't have the time for to start from the beginning and to learn everything toward the end. So the only possibility is take your PYQ questions and whatever the concept, go back to that and study it properly so that you can do the same concept if it is repeated. So here this you can see boiling point order they have given correctly, and the melting point order also they have given correctly. So this is also a PYQ as it is repeated. It is not maybe asked in the direct statement questions. Here they actually like made a lot of statement kind of questions. It was directly given with this order in PYQs if you see. So this is how the questions of all the PYQ you take it and make sure you know that, and all the concept related to that also you make sure you know that. Now another example is for physical chemistry usage. This is from K equilibrium. So the question is that A is converting to B in 1 liter flask, At T Kelvin, the equilibrium concentration of A and B are 0.5 and 0.375 molar respectively. So at the moment you are getting the question, you just write that here 0.5 and here 0.375 molar. Since it is in 1 liter, you can say that it is number of moles also, because C is equal to N by V, therefore N is equal to CV, therefore definitely 1 liter, so C is equal to N. So 0.1 moles of A is added. So this is equilibrium concentration. You are adding A into flask heated to T Kelvin. So make it the temperature same to establish the equilibrium again. The new equilibrium concentration of A and B respectively they are asking. So you are adding something A. We know according to Le-Chatelier's principle, the equilibrium is, the equilibrium is shifting forward, right? The reaction will shift forward. So based on that, if you are adding this A, for example, A gives B 0.5 mole, here you already have 0.375 mole you have already in the equilibrium. You are adding it something here, so you are increasing the concentration of A, then it will convert to product we know. So how much you added? 0.1 mole, so 0.6. From that how much something will be reacted and it will form here something, right? So plus X. So we have to actually find the value of X and we have to find out the total this also, because A and B are added. Now what is the concept behind it? One is Le-Chatelier's principle. So make sure you know Le-Chatelier's principle, very sure all the concept behind the Le-Chatelier's principle. Now what you have to do? You know that K equilibrium is only depend on temperature. It will not change on other thing. So K equilibrium remain constant, that is 0 product upon its stoichiometry divided by reactant. So this value should be equal to the new equilibrium created, that is 0.375 plus X react divided by 0.6 minus X, right? So you solve it, you will get the value of X. So this concept, for that one thing, you know how to calculate K equilibrium. What are the factors determining of K equilibrium? Only temperature dependent. That's why we can apply this, because if temperature changes, then we cannot say it. K equilibrium will change, but here temperature is made constant. So make sure you are analyzing each and every question's part and why we are doing like that. So you make sure here K equilibrium, all the kind of K equilibrium relation you know. So it will be repeated again. Already K equilibrium question has been repeated again a lot. Just you have to make sure you are knowing the concept very properly. Okay. And next question, for example, you can see here. It is from, actually it is not a question actually. This is, I have taken an example to make you sure or to make you learn that how to read an inorganic. Because for inorganic, P block, D and F block, completely you can depend on the NCERT. You don't want to go for anything extra. NCERT as it is you read for inorganic, not only inorganic. Actually there is a solution chapter you write. From there also inorganic is that's NCERT direct question. So wherever you are dealing the concept, make sure for that reference you are using NCERT. Don't need to go for any fancy books or anything else for the conceptual understanding or any theoretical part. Just prepare on NCERT only, right? The almost, you can see here, why I took it here, you can see the almost identical radio of zirconium 160 picometer and hafnium, that is 159 picometer, a consequence of the lanthanide contraction. The reason is that, okay, why they have same, you must be knowing that D block, if you have already studied that 3D, 4D, 5D, 4D and 5D series identical radius, unless these family, because lanthanide contraction is not here, so it is not applicable, radius will increase. But all other case, you must be have already studied that 4D and 5D has similar radius. Why it was lanthanide contraction? Account for their occurrence together in nature and for the difficulty faced in their separation. So what the reason for this is, okay, the reason why they are occurring same compound together in the nature and difficult faced in the separation is actually this one. So it can come as an assertion reason, right? So you just have to note out wherever therefore account for because of that due to, like kind of words are coming, make sure you are underlining it, and it is uh, like you are just highlighting it so that you are revising it again. Such things are very important. And not only from inorganic part, for example in solutions, one questions came like about the kh. I don't know you have noted it down or not. That is actually assertion reason. It concept behind it was that kh, we know it is a Henry's law constant, right? Henry's law constant, we know that it is also depend on different gases. O2 will be having some gas like constant value, H2O was having some other constant value, all other gas N2 or something will have another constant value, like that. Like different things is there. But there is a particular thing which we didn't note is in the heading of that NCRT, that value of this O2, H2O gas KH value, they have clearly mentioned KH value for some gases in a solvent water, in a solvent water. So whatever value they have given was in a solvent water, which means kh value is as it is a combination. Okay, O2 in water will be having one value, O2 in some other solvent will be having some other value. So if the solvent changes also, kh value will change. So based on that also some question has been created. That's why I said, if you have to know anything about the theoretical part of anything, just go and check on in your NCRT rather than checking of any other things, sources, multiple sources. So NCRT is more important for as a chemistry point of view. NCRT is better than enough, like than anything else. So if you do like this, make sure the all the PYQ you are covering, and that concept you go and, like if it is a theoretical part, learn the NCRT and come back. Because why I'm saying now you don't have the time to learn from the beginning and start one by one. What you can do is take the PYQ and go and learn the concept again, do it. So this will definitely help you, because if you see all the trends till now, PYQ as it is concept is repeated, even though the direct PYQ is not repeated. Now about the organic part. So organic, how to deal organic, I will just say that organic, even now if you start from the basics again, you will be struggling a lot. So if you do one thing, that write all the reagents from a particular chapter, especially the important things again from the PYQs or something you feel like. Like the main important things and all is diazonium chloride, how to convert this to the different things. So just write the reagents. For example, if I'm just writing sodium in liquid ammonia, just write the reagents alone, like Birch reduction. So such things, just write your reagents alone in a particular paper, and make sure you are constantly revising each day. Sidewise you are covering the organic. So you don't want to give a separate day for organic, because there will not be no time. If you separately give the time for organic, you can give it, but additionally also you require time. That's why I'm saying every day of that you take a particular time to write all the just reagents alone, nothing else, just reagents alone you write, which makes you more difficult to remember or something like that. If you know already very sure, then no need to write that, because you already know that you will get the mark from there also. So other reagents you just write, simply I'm writing something like, which one, HNO2, like HNO2 first one, that second one I am writing, okay, first one I am writing HNO2, second one I am writing something like sodium in liquid ammonia, other one I am writing like H2 palladium in barium sulfate. It's like something like whatever you know, right? It's not like that. Whichever from the chapter, for example, in hydrocarbon, we are using Mn2O3 somewhere, right? In the oxidation part and all, catalytic oxidation, copper. So these all you just write as the reagents alone, and make sure when I'm saying this HNO2, when I'm seeing this HNO2, you should be able to think about this is used in the diazonium preparation, NH2 to convert this one. Just you have to think it in yourself. So every day you are doing the revision of that organic without taking much time of your studies, so that the sidewise other also will done. So better you are keeping a list of reagents in your hand, in your study table or somewhere, that you are constantly revising that, so you will not forget it. It will help also. So for an organic point of view, you can use this method and some of the stability of intermediates and all GOC part. Thank you.